This is a demonstration of Boyle's law for National 5 physics. So this is the equipment we're going to be using. This is a Boyle's law apparatus. It is a glass tube with a sealed mass of air up here, a column of liquid connected via this pipe to this chamber. The pressure in here is read by this pressure gauge, and we've got a vacuum pump connected to the back of it. It's important to note that this is a fixed mass of air. There will never be any more or any less air in here than is currently in here. It's a sealed glass tube at the top. The only opening in this entire system is out the back of this chamber to the vacuum pump. So what happens when we turn the vacuum pump on is it draws the air out of here, which causes the liquid in here to go down and the air in here to expand to fill the volume left behind the liquid. Again, there is no change in mass in this air. There's the same number of air molecules in here as there always will be. So let's turn the pump on and see that in action. I'll give it a minute for the tube to clear. The liquid in it stains the glass a slight amount. So here we have the pressure gauge reading almost zero, almost in kilonewtons per square meter is the unit this is using. And the volume of liquid is below the bottom. You can barely see it just at the bottom there. Again, it's important to stress that no more air has actually been added here. This is the same air that was there before, and the temperature of this entire system hasn't changed. We can ignore temperature for the purpose of this experiment. We're only concerned with volume of air and the pressure of the air. Hopefully you can see from this, as the pressure is extremely low, we've got a large volume in here. That should give you a clue to the relationship between pressure and volume. What I will do now is open the release valve to allow air back into the system, increasing the pressure here and decreasing the volume here, and see if you note any difference in the rate of these two. I've opened the valve an extremely small amount, and as you can see, the liquid is rising rather rapidly, but the speed of the needle is almost completely stationary. I open the valve slightly faster and hopefully get the needle to move. Note that the speed of the liquid is beginning to slow down, indicating that the pressure here is increasing and the volume is decreasing. Note that this is still only about half atmospheric pressure, and that is how much of the column we've got left. I'll open it further. And there we go, back to atmospheric pressure. Note that the liquid here isn't particularly relevant to the experiment. It is just used because it is incompressible, unlike the gas, which you can compress and expand.